In this video we'll talk about interfaces in TypeScript. So the first thing that we want to do is we want to install TypeScript globally if you haven't already done so, with the npm install -g flag for globally and TypeScript. And then what we'll do is we'll create an index.html file. And if you can use exclamation mark and get up boilerplate, and just below just above the head tag where it closes there, we can have our script with the source, and we can call this file interface.js, which we haven't made just yet. So we can save that, and if we make a new file, index.ts, this will be compiled down into JavaScript. For example, if we just had let x equal 5, save that, what we can do is what we might do actually is we'll download, we'll initialize the TypeScript config, so we can go tsc-init, and the reason I'm doing this is so we can use the tsc-w command just in case we need to watch all of our TypeScript files. And so this tsconfig, what it's doing is it's changing our TypeScript code, so let x equals 5, and it's compiling that down into ES5, and notice that this has created the index.js file using strict and var x equals 5, so it's just compiled it to ES5. So yeah, that's the configuration. So now we're writing in the index.ts file, so we try not to touch the JS file. So yeah, let's talk about interfaces. So TypeScript interfaces is the main topic for today. So what is an interface? An interface allows us to declare and enforce the certain structure and type of an object. So to give you an example, let's say that we have a person. We can have this interface person, and notice the capital P. We use a capital letter for the interface, Pascal case. And so a person can have a name, and they can also have an age. And we sort of assign each name, or each object's property to a type. So rather than a key value pair, it's sort of like a key type pair. So name, that will be string, and we're using all lower cases here because we're not doing anything fancy. And if you're not sure about these types, I have a video on both the basic types and the advanced types, so check out those, and also compiling options if you need more. But yeah, so this interface is like a blueprint for a particular object. So in this case we have the person object, and every person has a name and every person has an age. So let's skip that, and we assign the age to a number type, and there we go, this is our first interface. And what this interface does, it allows us to enforce this structure. So let's say we create person 1. We can say person 1 is of the type person, which is equal to this object, which must have a name, so John, and has an age of 25. And notice the difference between the interface and the object declaration. Well, in this interface we have the key type pair with a semicolon terminating each line or each assignment type, whereas in the when we actually assign the object or the person type, it's just JavaScript object notation with the curly brackets and comma separated key value pairs. So what this will allow us to do is it will give us IntelliSense. So P1, and we can see that we've got an age and we've got a name, and that's really handy, and it also allows us to not add any additional. So if we have, say, P1 dash last name, that equals to I don't know, Smith. Well, we can't just append that now, or add that property. But there may be certain circumstances where there are some properties that may or may not be present, and for that situation we can use a optional property. So let's say, for example, a job is an optional property, and the job is of type string, let's say. Well, if this person doesn't have a job, we can go ahead and give it the optional property by using this question mark before the colon. So that's how we can get around that. And then optionally, if we wanted to, we could add a job here, say as a programmer or something like that. Okay, so that's an introduction to some of the basic interfaces. Now we'll extend on that, and we'll discuss say read-only properties. So let's just comment this out for now. And let's say we make an interface for a point, so point on a 2D grid, and this will have an X value, which will be a number, and we'll have this Y value, which will also be of the number type. Now, what we can do is we can assign this X and Y number to be a read-only. So we can do that with the keyword read-only. Read-only. And read-only properties are properties that are only modifiable when an object is created. So for an example, let's say we have point 1, and this will be of the type point, so we're enforcing this structure, so we're expecting point 1 to be an X and a Y value. And what we can do here is we can assign X to any number, 1, and we can assign Y to any number as well, so we can have, say, like that. And I just forgot the equal sign here. So yeah, we can construct a point by assigning it here to this object literal. An object literal is just basically an object in JavaScript. So what we can't do now is we can't say p1-x equals to 5. So before we could change that, we went into the IntelliSense. Actually, I don't think we actually did that, so let's just do that, and I'll comment this out here. So what we could do in this certain circumstance is we could say p1-job, and then let's say I go from a programmer to a full stack developer, and once again that's reassigning it. So in this sort of object that's enforcing this sort of structure here, we can actually change these properties. But if we sort of want to mitigate or protect against any changes, say like a point is in a fixed location and it's definitely not going to change, what we can do is we can do the same thing, but we just add this read-only, so the properties can only be modified when they're first sort of assigned. So this here, that's no good to us. Okay, so let's continue talking about read-onlys, and we can talk about it in the context of an array. So let's just make an array. So let ARR for an R be of an array of a type number. And notice this here is the exact same thing as this here, if you haven't seen this form before. And okay, so let's go ahead and assign it. Let's say 1, 2, 3, 4. I'll just say that's the prettier extension word. Reformat. So I've got prettier in VS Code, and I've also got live server, which we may use a little bit later on. So there's the two main extensions that you need, although not completely necessary if you don't want to install them. But anyway, so we got this array of type numbers, and let's just see. So if we wanted to, we could say let the array, let the first element equal 0, let's say. And what they'll do is they'll change the first element to 0. They'll change the first element to 0, but let's say we had like a sort of fixed array of numbers that we didn't want to change. What we could do is we could say let RO for a read-only array, and this will be exactly the same basically, but we prefix it with the word read-only array. That's all one word for arrays, and this will also be of the number type. And let's say that we set this equal to our original array, 1, 2, 3, 4. What this will do is it will avoid us from mutating that. So it removes all of the mutating methods and everything that can allow us to mutate that. So for example, we could have, say, we may want to test that this works by assigning the RO array equal to 0, the first element, and now in this case we do get the error, which is what we wanted. And TypeScript's all about sort of compile time errors, so it points them out before the application actually runs, but of course it'll still compile it. It's up to the programmer to take the feedback on board and make sure it's not error prone code. So another thing is like the methods, like the array methods also won't allow us to mutate it, like such as push, for example. Yeah, so we sort of use the read-only for properties usually associated with an object. So we've seen it associated with this object here, and you know we can have a read-only array like that. So that's not going to work. So let's go home, get to the front of the line, comment this out, and okay. So let's say we have a constant, and we'll call this P2, and this will be assigned to the object literal, where x is 1, y is 2. Yeah, so we've sort of seen this, that if you say p2.x equals to 4, that's all good to change it like that. But, you know, where TypeScript sort of allows us to have the read-onlys, if you put a read-only here, just before you have the name of the variable. Oh, sorry, that's an interface. Okay, so we won't go through that again, but just re-emphasizing that you can reassign it this way, but the read-only you can't reassign it. so that's all good. So this sort of leads us into when would we use, let's say, constant variables. And it should be noticed that this can be reassigned, but not reassigning or redeclaring the constant, just adding it to the list, so to speak. So even though this is a constant variable, one thing that might be a bit confusing is, okay, if this is constant, then why can we change this? And constants for the more primitive types like booleans and stuff like that, they can't be reassigned or redeclared. But this point here, it's more pointing to the address that this variable is set at. So it's not pointing to say number 1 in particular, it's pointing to a location in memory, so to speak, that points to this object. So what this is doing here is it's not redeclaring the variable, because we're not redeclaring it in any way, but it's also not reassigning it, because we're just sort of changing one of the list items. We're not changing the actual location of what it's pointing to. Whereas if we had, say, constant, just call it x equals 5, we can't reassign this to x equals 6 just in regular JavaScript, because it's a constant. So so that sort of leads into, let's say we have a constant for my height. Let's just say height. And notice that I've used all uppercase letters here, so constants that they shouldn't change at all. And to sort of emphasize this, we sometimes use all uppercase letters, sometimes not, but sometimes, yep. So we're using this sort of notation for constant variables, so we'll just keep that in mind. So one thing we might want to take a look at is excess property checks that are done in TypeScript. So let's say we have this interface and we have a square interface, and a square is a color and a width, and they are of type string and number respectively. So a square, so let's just say we create a function, create square, which takes a square of the square type, and what it will do is it will return an object with a color of type string and an area of type number. So we give this function a square with a width and a color, and we'll get back the color and the area. So as an object, so we'll say let area equal whatever square got passed to its width multiplied by square times, dot width again. And what we'll do is we'll return this object where color is equal to square dot color, so just what we passed into it, but the area will be the area we just calculated. So so that's the return type. So what we could do is we could say, okay, let my square equal create square. So we're calling the create square function that we just created, and as a parameter we pass in, say, the color of the string type, which we can say it can be red, and we can pass in a width, and that can be 2, let's say. And then let's go ahead and console log my square. So we've saved that. TypeScript compiler is constantly watching for that, which creates this index.js file, which is our ES5 JavaScript, which is in our script here. And I might just add the word defer here. Thought I did that before. So the page can sort of pass first before the script. Thumbs up. So okay, so if I open up live server, where is it? Oh yeah, sorry, that has to be in the HTML file. So open up live server, close that, and this will bring us over to our live hot reloaded page. So if I go F12 here on the developer tools, okay, we don't get anything, and that's because I've used interface here. You probably picked up on that before. That should be index.js. And if we take a look, ignore these errors. There's something going on with Google at the moment. But we do notice that we get this color of red and area of 4. And that's what we expect, because 2 times 2 is 4. Yeah, so let's sort of extend that. And okay, so let's say that we have a second square, and I might just say, okay, but let's say we pass another property in, and there could be heaps of properties. Like there could be an opacity of 0.1, you know, there could be any other number of things, such as has border, does not have border, and we may not necessarily know all of these properties, or we may not want to define all of these ahead of time in our interface. But what we can do is we can realize that, okay, every sort of property is like of a string sort of type, and it can have any type. So opacity is 0.1, but has edge. That's maybe that's true, and it could also be of a string type. So let's see here. I can't think of anything off the top of my head. Let's see. Let's say category, and the category might be, I don't know, maybe it's a new, maybe we just made this square and it's new. I don't know, it's more to illustrate the types. But what's going on is, why these are errors, is these aren't in the interface, but we might not know these. But what we can do is, if the square has any number of properties which don't, where the type could be anything, what we could do is we could just say for whatever the prop name, so whatever the property name is, and that's a string, because, you know, opacity has edge, category, that's all strings, no sort of indexing or anything. and we can return anything because we're not really sure at this stage what that will be. And perhaps what we could do is we could say unknown, which is slightly better than any. I sort of just wanted to write unknown because I never really get a chance to write unknown, but we could just use it in this circumstance. And now we'll see that there's no errors, and the types aren't enforced. They're only enforced for the color and the width, which we've defined earlier in the interface. So yeah, that's the types, how we can assign a type to an interface where we're not sure of the number of properties. Okay, so alright, I suppose we can talk about interfaces that include functions as well. So let's say we have an interface and we'll make a search function, so I'll say search fn. And okay, so the way this works is we pass the core signature, which is composed of the parameters and the return type. So the core signature, so let's say we have the search function, and we have a source, which is a string, and then we also have a substring, so we're searching for something from the source. We type in a string in this substring, and it will do something. I won't go into much into the implementation details, but essentially we type in a string, we're searching this against another string, and if it's successful we'll return true, if not it will return false. And this sort of interface can be used. So yeah, this is the core signature. This whole thing is the core signature, where we have our parameters in this sort of like the same as it would be in where the arguments are in a function sort of thing, and we have the return type. So we can say, let's say we search for something. So we'll say let my search be of this type search function. So now we know that we need to sort of enforce this interface for our function, meaning that if we assign my search, it needs to be equal to a function with the source string and the substring string, and we know that this needs to return a boolean. So we can say, okay, let the result equal source dot search substring, and we can return the result, and then we can evaluate this expression. So if the result is greater than -1, then okay, so what this is doing is it's taking a search term. So let's say we have the search term with the source. We're looking for, say, the source is happy, and then we type in HA. What this function is doing, and this is built into JavaScript, is for this particular word happy, we're searching for this substring HA, and it sort of finds, it returns a number, and I don't know what the number is exactly, maybe it's 1 or something like that if it's true, and 0 if it's false. But anything, if it's 0 or 1, it doesn't matter, because anything greater than -1 will return true, which may mean -1 could be the false result. But anyway, that's sort of getting into more of the implementation. I'm sure that can be found on the JavaScript docs or something like that. But yeah, the point is we're implementing this search function interface, and we use this core signature, which is composed of the parameter list and the return type. And then when we implement that on our variable mySearch, it must enforce that sort of type. Okay. So the next thing I want to talk about is the indexable types. So what is an indexable type? Let's just start off with an interface. We can see now we can make an interface. We use the keyword interface, and we'll make a string array. And okay, this will have an index signature, and the index signature states that when this string array is indexed with a number, it will return a string. So let's see that definition. So we have an index, which is a number, and for that index we will get returned a string. So for example, let my array be of this type, string array, and we can assign my array equal to an array of names, let's say. So we can have Harry, Larry, and okay, so we can also, let's say, so what this will allow us to do is it will allow us to say, let my string of the type string equal my array, the 0th element. So what we're saying is, let's say we have this my array, which is an array of strings. When we search for one of these strings, like say we search for Harry by looking up the 0th element, we know that we're going to get a string back. But the key difference between a regular array is that we've sort of predefined that we will get a string back through this interface. So we've sort of said, okay, we're definitely going to get a string back whenever we sort of index the array. So we use this sort of square brackets to sort of suggest that if we create my array of the type string array and then we index it with this sort of form here, we will get back the specified type of the interface. So yep, that's the indexable types. What I might do now is I might talk about implementing an interface on a class. So the different class types, and this will enforce the class to meet the required structure. So the interfaces describe the public side of the class rather than both the public and private side of the class. So that's just something to keep in mind. But if we have an interface, and we'll have a clock interface, and our clock interface will have a current time of the type date and a set time, which is a function that we can set the time of the clock with. We can set the time with a date. That won't return anything, so that will just return void. And we can have this class clock, and that implements the clock interface, meaning that structure of the interface applies to the public, so the public property and methods of this clock class. So meaning that it must have a current time and a set date function, and I'm not sure if it can have any other. Let's just check it out. So we'll say the current time is a date equal to new date. Set time, and these signatures are just from the interface. So set time, that's a function that just takes this dot current time, and that will be equal to D, which we need to make a constructor. So since we're in a class, we can make a constructor, and the constructor runs every time a clock object is instantiated. So if we have H with a number representing an hour, and M with the number representing a minute, meaning when we call this function, with the new keyword, new clock, we need to pass in the minute and the hour. And that minute by hour, there might be some implementation details that need to be addressed, but the idea is that we can sort of enforce this type here. So current time of the type date, yep, and the set time function takes a date and returns this current time to whatever we passed in here. And I just wanted to sort of see, and I think usually what we do in classes is we usually put the method below the constructor, and I just did want to see something out of curiosity. So let's say we have an alarm of date equals new date. Okay, so that it does allow us to add extra things, so we're not strictly tied to this interface, I suppose. I suppose if this has to be private or something like that, because the idea is to enforce the public side of things. Yeah, okay. So what we can do now is we can move on from classes and interfaces to extending interfaces. So let's say we have an interface called shape with a capital S, which is of a color, and then we have our interface square, which extends shape and has a width of, say, number. Now what we've done here is we've used this extends keyword, and we've seen this in other object-oriented programming, but it applies to the interface as well, which means it will have all the properties and methods associated with the interface that it is extending. So shape has a color, so square's gonna also have this color because it extends a shape, and it will also have a width of a number type. And we can extend extended interfaces, so we can just keep chaining these on if we wanted to. So let's say we have this interface rectangle, and that extends a square, because every rectangle, no wait, hold on, every square is a rectangle, but not every rectangle is a square. So every Wait, what's that? No, that's not right at all. Forget that. Scratch that. Every square has a width, but every rectangle also has a width. But a rectangle will also have a height associated with it. It could be the same, but it may be different. So we need to specify that. And so every rectangle has the properties and methods of the square and the shape. So every rectangle has a width and a color, but it also has a height. So we can continue to use this extends keyword to keep extending our interfaces, and we can just actually see that. So let's say we set rectangle 1 equal. Oh, and one thing we can do is we can sort of, there's an easy way to get around like say we would regularly say let rect1 be of type rectangle, and then this will error. We can get around this with type assertion, meaning if we don't have this object literal in the same shape as the interface, a very easy way to get around this is we can sort of use type assertion. So we can use this as keyword and say as rectangle. So we're telling TypeScript, okay, it's definitely a rectangle. And that what that will allow us to do is that will allow us to set the rect1, the properties after at a later stage. So we can have rect1 color equals to red, rect1.width equal to 2, and we might have rect1.height equal to 1. Okay, so that's sort of inheritance. So yeah, that's all I really wanted to talk about on interfaces. So we covered basic interfaces, optional interfaces with this question mark. We know that we can define interface with the keyword interface and use a capital letter. We had a look at read-only and why we would want to sometimes not reassign any objects or arrays. And then we had a look at the constant keyword. We had a look at an unknown length of properties. So if we had extra properties but we're not sure of them in the interface, there wouldn't error when we implement that interface. And we see an example of functions and interfaces. So we use this search function here. We also had a look at indexing. So indexing an array, putting in a number and expecting a string back. Then we had a look at classes and interfaces, enforcing that the class has at least these two properties and methods within them. And then we had a look at inheritance. So we covered all the basics of interfaces. So what I want to do is in the next video I want to discuss generics.